Howdy folks, welcome to Organic One Lab. This video is going to introduce you to the program ChemDraw, or sometimes referred to as ChemBioDraw. It's a drawing tool for people wanting to illustrate chemical structures, reaction mechanisms, and a lot more. It's available to all Juniata College students, and it's going to be an essential program for those students, or most students, who are planning to pursue a chemistry or biochemistry degree. So getting to know how to use it effectively and efficiently is going to be pretty important. And this video is going to walk you through a couple of tips and tricks. It's going to show you how to reset some of the settings of the program so it works better for you. If you don't already have ChemDraw, what you're going to have to do before this video is go onto the Juniata website and download it. So you can just Google Juniata College ChemDraw, and that should take you to the correct TSC help page that will allow you to download the ChemDraw program. If you downloaded the program last year, you might want to go in and re-download the program, because each student license, even though all students have access to the program, each student license only lasts 1 year. So you have to renew that program every year. So if you downloaded it last year, please take the time to reinstall the program onto your computer. All right, let's get started. So a couple of things. So once you download the program, what you can do is you can pull that icon from the applications folder into your dock, and that way ChemDraw is going to be really easy and quick for you to access. So you can see here I have ChemDraw version 19, and if I click on ChemDraw, that should bring up my screen to look like this, right? So we have up here, we have the actual drawing palette here, and then we have a couple of toolbars. So if you don't see all of these toolbars, so there are, get back in here, there are 3 toolbars here, and if you go up to view, you can see they're called the main toolbar, the general toolbar, and then the style toolbar. And so these are those 3 toolbars here. If you don't see these 3 toolbars, they might not be in the same location. Right, so you can move these around, but if you do not see these 3 toolbars, go up to view and just click on to make sure that the program is showing those 3 toolbars for you. The other thing I want to say before we get started is that this program is extremely useful, but it's a lot easier to use if you have a mouse. It's very possible to use if you have a trackpad. In fact, I use it with my trackpad a lot of the time. But a mouse really helps make this program a lot easier to use. So if you have a mouse, whether it's a USB mouse or a Bluetooth mouse, whatever, it doesn't matter. Just having that little device will give you a little extra agility when using this program. Like I said, you can use a trackpad. That's fine. If you don't have a mouse, don't worry about it. But if you do, why don't you go ahead and grab it and hook it up, and that'll be easier for you to use this program. All right, so we opened up the program. You can see when this opens up, it opens up to a single blank page. You can do a couple of things with this blank page. So some of you might see a blank page with these crosshairs or with this grid on it. You can make that go away by just clicking on Show Crosshairs, or you can make it come back if you like them there. I'm going to leave them off for the time being. You can see on this toolbar here, we have all of these buttons, all of these little tools. And what you can do is you can pause this video, take some time, click on these tools, and just see what they do. I'm going to take you through a couple before we change the settings in this program. So probably the most frequent tool that you're going to use is this bond tool. I'm going to zoom in a little bit here. So these are the zoom in and zoom out functions. I'm going to make my screen a little bigger. And then when I click on this bond tool, you can see it draws a bond between 2 carbons. So this is considered a carbon here. This is also considered a carbon there. You can see when I bring the cursor to the end of one of those, at the end of either end of that bond, there is a blue dot that shows up on the end of the bond, right? That tells you that the cursor has grabbed onto that atom. And there's also a little dot going off, in this case, going off to the upper left of the blue dot. In this case, it's going off to the bottom right. So if I put my cursor on the end of the bond and I click again, you can see it draws a third carbon and a bond to that third carbon. And that third carbon goes in the direction that that little dot was oriented, right? So right now you can see the little dot is oriented down. If I just click once on that central carbon, it's going to draw another carbon going down, right? Here you can see that the next bond that it draws should be going down and to the right. And in fact, it does that, right? And you can see that I can keep going and that the new bond will always be drawn in the direction of the small dot that's around the blue circle. If you don't want the bond to be drawn in that direction, so say I don't want the bond to go down this way, what you can do is just click and then drag in the direction that you want to go. Right, so I can do this and I can draw a complete 6-membered ring. If I want to draw double bonds, I can click on the bond that I want to make a double bond, right? Triple bond. Oh, that's all right. I'll show you how to make triple bonds in a little bit. If you don't like the orientation of the double bond, just click and it'll put the other line outside, or it'll center that double bond in between the atoms. Alternatively, right, so I just drew this benzene ring. Alternatively, if you go over to the toolbar again, you can see there are templates for different structures. So if I just want to draw a benzene ring, rather than drawing it freehand, I could click on the benzene ring, drag the cursor to the atom where I want to put that benzene ring, and then draw that benzene ring. Right now that you can see that the atom that was there was incorporated into the benzene ring already. Alternatively, if I want to draw, rather than drawing a benzene ring to an atom, if I want to draw it on a bond, let's see here, if I want to make 2 carbons of this part of a benzene ring, I can do that there. Move this over. All right, so rather than drawing these rings freehand, or a lot of these things freehand, you can use these templated structures. So there are, cyclopropane, cyclobutane, multiple rings. Alternatively, also, if you want to draw a long chain, so say you have an 18 carbon chain that you want to draw, rather than coming here and clicking, right, and clicking 17 different times, you can come down here to this tool, and this will allow you to draw a chain. It will tell you how many atoms are part of that chain. So if I want to draw an 18-member chain, there's my 18-member chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If you want to delete, say you made a mistake and you look back and say, oh, I only needed a 16 carbon chain. Well, there's an eraser up here. You can click on that carbon and it will erase that carbon. Click on this carbon. Now you have a 16-member chain. If you want to delete more rather than going delete, you can highlight a section. So you can see these 2 tools up at the top are the highlighting tools. If you click on either one of them, it will always highlight the last structure or the last item that you were working with. So if I highlight this, I'm not going to delete the whole chain, but I can draw a box around the atoms that I want to delete. So I want to delete those atoms or those bonds. There we go. If I want to delete that last one, it will usually end up highlighting that last atom. If I want to delete it, just press delete again. So what you can do is go ahead and click on a lot of these tools, play around with them for 10 minutes and just see what they do. Get used to drawing structures, get used to seeing what these other tools do. Some of the neat things that this program allows you to do. There's a TLC tool, so it allows you to draw TLC plates and set spots at specific retention factors. There is a bunch of templates. So if you want to draw amino acid side chains, carbon nanotubes, right? So this gives you a bunch of different nanotubular structures. Look at all of that. You even have templates for glassware, right? So if you want to illustrate in a lab report or in a post lab what your reaction setup look like, you can use these pieces of glassware to show that you have a round bottom flask, and then that round bottom flask is hooked up to a distillation head, right? And so I can take that distillation head and move it to the round bottom flask, right? And then I can continue to add glassware onto that. All right, so go ahead and play around with this for a little bit. I'm going to delete all of these things that I have on this page, zoom out a little bit. So to delete everything, what I can do is if on my Mac, I can press Command A, and that selects everything, and then just hit delete. And what I'm going to do now is just draw a really simple reaction. And we're going to take a look at these structures and compare them to structures in some new settings I'm going to ask you to change to. So we're going to look at the hydrolysis or the hydrolysis of an ethyl ester. And I'm going to show you how to do all of these little tricks so it makes drawing a little more effective. But I just want to get this drawn in here first. All right, and we're going to say that this happens in HCl. In acid, water, and heat. Okay, so this is a reaction that you'll learn later on this semester in organic lecture. And this just illustrates what we call the hydrolysis, or the acid catalyzed hydrolysis of an ester. We're starting with an ester, we're ending with a carboxylic acid. All right, so I'm going to keep this here, and then we're going to change a couple of the settings, and I want to show you how the settings are different and maybe provide some rationale as to why we're changing those settings. Right, so you can see this this scheme takes up maybe a fifth of the page. All right, so what we're going to do to change the settings, what I want you to do is go up to File, and you are going to go down to Apply Document Settings From, and then we're going to go to ACS Document 1996. All right, so when you do this, I make sure that your page is completely blank. You don't have to draw this reaction like I have. I'm just doing it in this video to illustrate how the settings are changing from what we're given and what we want to actually have. So ACS document 1996. I'm not going to modify the existing settings because I want to use those to compare to the new settings. All right, so that gets you to a certain base, and then we're going to go in and modify individual settings. So if you go back up to File, and you go down to Document Settings, that's going to bring up a window that allows you to change settings under all of these different categories. So the first setting that we're going to change is under Layout, and what we're going to do is we're going to increase the page size from just a 1x1 page, so just one page, and we're going to increase that page size so we're using a 3x3 page document, so basically 9 pages. And what this does is it allows the document, the file that you're working with, to be large so you can fit a lot of different structures on there. So if you're working on a homework assignment or a paper where you need to draw a bunch of different structures and you want all of those structures in one file, by increasing the page size, we can fit all of those structures and save in one graphic and save them under one file. So that's the only thing you'll do there. Next thing, you'll go down to the drawing category. We're going to change a couple things in the drawing, and really we're going to focus on the bonds or the lines that we draw in this program. So we're going to change the bold width from 0.0278 to 0.03. The line width will be changed from 0.0084 to 0.015, and then we're going to change the hash spacing to 0.025. So we're going to decrease that a little bit. All right, and those are the only 3 changes that you need to make here. If you go down to text captions, we're going to change the text, so the default should be Helvetica. You can leave that font, but we're going to change the font size to 9. And then if you go down to atom labels, we will do the same thing, just change the font size to 9. And then those are the only changes you need to make. So once you're done, you can hit OK. So you don't need to hit OK with each change. As long as you change everything and then hit OK, it should accept those changes. I'm not going to modify what I already have on the page. All right, and so you can see it provides me a much bigger piece of paper to draw all of these structures on. Right, so this was 1/5 of the page. Now you can see I can get a lot more structure into this document. I'm going to zoom in onto what I've drawn, and I'm going to redraw it. And hopefully you can see how these settings are changed, right? So you can see the structures are smaller, and the atom labels are about the same, but relative to the structures that are now drawn, they're larger, right? So that ratio of structure to atom label or font size is smaller than what it was up here. All right, we're going to draw the carboxylic acid, and then we'll put in an arrow. Make sure we select the correct arrow, and then put in our reagents. All right, so these are the default settings for ChemDraw, and these are the settings that I want you to create for all of your ChemDraw documents. All right, so you can see there is a difference, right? These are smaller structures, so we should be able to get a lot more structure into one file. You can also see here, and this is really nitpicky, right? You can see that the font for the chemical structures is different than the font that we put in for the reagents. I think it's good to be consistent, and you can see here there is consistency between those fonts. You can also see that this bond size is maybe a little bit bolder than this bond size, so it makes those structures pop out more. You can see this arrow, the arrow width, or the boldness of that arrow, it's more bold than the other arrow. So I think these settings look a lot nicer. They're a little more user-friendly. They're kind of the standard settings that organic chemists and a lot of chemists use whenever they draw structure in ChemDraw. All right, so I'm going to erase the original structure, and then I'm going to ask you to do a few things. So what we're going to do here is we're going to save a file that will we're going to save this file so that whenever you open up ChemDraw, it always opens up ChemDraw to the correct settings, the settings that you just set. All right, before we do that, I'm going to draw in a couple of things. So first thing I'm going to do is I'm going to put an arrow up here in the upper left-hand corner. All right, and I'm going to change that arrow. You don't have to change the arrow. I like having my arrowhead a little shorter than the standard ChemDraw arrow, but that's my preference. You can do whatever you want. The next thing I'm going to do is I'm going to come over to what's called the pen tool and click and hold down, and you can see that there are two different pen tools. I'm going to click on the right-hand side pen tool that has these little dots on it. Right, and then I'm going to draw with this pen tool. What I'm going to do is I'm going to click once, right? You can see it puts a little diamond in that spot, and then I'm going to click a second time, and it draws a line, right? It puts another diamond and it draws a line between those two diamonds. You can see that the hand, right? The cursor is a hand with a plus sign on it, right? And when I drag that hand over to the blue diamond, you can see the hand changes so it looks like a glove. And what that means is that this hand, or my cursor, has grabbed onto that diamond. When I move it off the diamond, right, you can see that the glove goes away. All right, so I'm going to zoom in a little bit more. I'm actually going to delete all of this as well, because we're not going to need this. And then I'll go back to my pen tool, and if I click on that line, it should give me those two diamonds again, right? And so as long as my hand has a glove on it and it's over that blue diamond, I can left click and hold, and I can drag, and you see that allows me to bend that line a little bit. Right? And if I go over to the other diamond, same thing, right? I can click and hold, the hand stays gloved, okay? And it allows me to drag this cursor and make this line into a curvy line, right? One thing to note, if I click outside of any of these little dots that I can grab, that's going to continue drawing the line, all right? You don't want to do that. If that happens, just hit Command-Z, and that's going to undo that process, okay? So once it doesn't have to be in any curve, just play around with it and get used to it to see how that curve functions. All right, and then you can if you put your hand over the line, somewhere over the line, and do a right click, it brings up this menu that allows you to put an arrow at the end, right? So you can see I started the line here, I ended the line there, and it has an arrow going that way. All right, so once you do that, I want you to highlight this, and we're going to change the settings just on this arrow. So go up to Object Settings, so Object Settings, and we're going to change the line width, decrease the line width to 0.1. So just delete the 5, hit OK, and you can see that makes that arrow a little bit skinnier. We're going to use these as mechanism arrows, and whenever you're drawing mechanisms in ChemDraw, it helps to have a thinner, narrower line and a smaller arrowhead, because a lot of the times those arrows are going to be small as they're when you draw mechanisms. Spaces often around structures are kind of tight. Okay, so you have these two arrows, and this should be good enough. And so what you're going to do, so once you're done with this, what this means is that whenever you open up ChemDraw, ChemDraw is always going to open up to give you this arrow and also this arrow. And the reason why we're doing that is because once you have these drawn, in ChemDraw, it's super easy to copy and paste things once they're already drawn. So if I click on that arrow and I, on my computer, hit Option, you can see that the hand, when it's in that box, has a plus sign. If I hold down Option and drag, it just copies and pastes wherever I drag that arrow to. And I could hit copy of the copy, copy of the copy of the copy, etc. Right? So I'll go back, just hit Control Z or Command Z, and that will take you back. And so the reason why we draw these arrows is that if they're always there, and you need an arrow, rather than coming over, clicking on an arrow, you can come up here, highlight your arrow, hit Option, and just drag it to wherever you want it. If you need to resize it, you can do that. You can make it shorter, you can make it longer, you can move it in different directions, you can change the size of the head. Right, but by having an arrow here, it's easy just to copy and paste. And when you're drawing reactions in organic chemistry, you're going to be drawing a lot of arrows. Mechanism arrow is the same. So we have this mechanism arrow. If we need to draw a mechanism, we can take this, move it to where we want it, and then if we need to change that arrow, we can go back up to the pen tool, get this unhighlighted, click on the arrow, click on the arrow, and then that will bring up these dots that allow us to change the curvature, change the size of the arrow, and so we're not drawing a new arrow every time. We're just copying and pasting and then adjusting the direction of that arrow. Right, so that's why it's useful to have these arrows in your file whenever you open up your ChemDraw file. Right, if we zoom out, you can see how big they are, maybe how much you'll need to adjust them. Right, so once this is drawn, I want you to go up to File, and we're going to save as stationary. So click on Save as Stationary, and you can name this whatever you want. So I will save this as, let's say, we'll save this as the ChemDraw Pandemic. So CD Pandemic. And it will save it into the stationary file. And if I hit Save, right, you can see it doesn't change the file name. So it didn't save it as that file, it just saved it as a stationary file. And so if I close that, you can delete it, don't worry about it, and you go up to File, and then New from Stationary, and you should find the stationary that you just saved. So CD Pandemic is what I just saved, and when I open that up again, right, you can see it saved that stationary with those two arrows. Now, if I exit out of ChemDraw and I open up ChemDraw again, as long as that file was the last stationary that I opened up, then that will always open up to that stationary, right? And it will maintain the settings that you inputted into the program, so it's not giving you the default settings. So that's all you have to do to save a file as a template or save a file as stationary, right? When you do save a file, that for a pre-lab or post-lab, just save it the normal way, right? You won't save every file as stationary. Only the files that you want to use as a default for your program would you save as stationary. All right, so a couple of tips and tricks. So under Moodle, you should see the instructions for this. So these are the instructions that you can download from the Moodle page. And on the back side of this, there are a bunch of shortcuts and tips and tricks that you can use to make your use of ChemDraw more effective and more efficient. Right, so let's go over some of these. Let me open or bring back ChemDraw again. And so I'm going to draw, let me zoom in here so you can see my structures. And if you want to, you can follow along with what I'm doing. All right, so I'm going to draw that ethyl benzoate, that ester molecule that we had before. All right, and so what you can do, you can draw your benzene ring, and then I want to draw the rest of the bonds off of this carbon. So I'll click on that carbon, click on that carbon, click on that carbon, right? And now I have to draw a double bond. So one way to draw a double bond is to just click on a single bond again, and that will give you the double bond. Alternatively, what you can do is you can highlight that bond. So just bring the cursor over the bond, and then on your keyboard, hit 2. And if you hit 2, it'll give you a double bond. If you hit 3, that will give you a triple bond. Now, obviously, this you can't have a carbon with 5 bonds to it, so this is wrong. But it does illustrate, that you can make multiple bonds. Oop. So if we just hit 1, it will go back to a single bond. We want this to be an ester group, so we'll do 2. The other shortcuts that you'll want to use. So usually when you want to write an atom, you have to go up here, click on the carbon that you want to change, and if we want to change this to an oxygen, we'll put in an O, hit return, and there's the oxygen. If I instead hit oxygen and delete, right, if I want to delete that atom, I can hit delete. Alternatively, I can put the cursor over that carbon atom, and if I want an oxygen, I will hit O on my keyboard, and that will automatically put an oxygen. If I want a nitrogen, change that to an N, and you can see it fills in the hydrogens for that nitrogen. It recognizes this as an amino group, and it knows that nitrogen usually likes to have 3 bonds. It's neutral form. So any atom or any bond that's not going to carbon, it will fill in automatically with a hydrogen, right? If I want to make this a carbon, you can see it will give me a CH2. This carbon now has 4 bonds. So let's go back to oxygen. Here, right, if I hit O, you can see it gives me an OH group because it knows that oxygen bonds to 2 things in neutral form. And here, there's only 1 bond, right? And so it gives the hydrogen to make up for that second bond. Right, now, if I want to make this into an ester, all I have to do is click on the O, right, and make an ethyl ester, and there are my 2 carbons. Okay, copy and paste. So if we're showing a reaction, right, let me show you what we're making. Right, so this is what we're going to make in the reaction. So rather than going back here, redrawing all of this stuff that you need to draw to make the carboxylic acid, right, which you can do pretty quickly for this rather small molecule, a much easier thing to do, let me delete this, I'll delete this, is to go up to one of your 2 highlight tools. So I usually use the square highlight tool. Other people like to use this where you can actually highlight around in a specific area. It doesn't matter, but once you highlight, you want to press your option. So you're going to basically just copy and paste this part of the molecule. And you can press Option, right? Hold down Option, and then drag wherever you want that molecule to go. Right, now you can see whenever I drag, let me highlight this again, whenever I drag, right, I can drag anywhere. Usually whenever you're drawing a scheme, you want those molecules to be aligned, the starting material and the product to be aligned. So what you can do if you want these molecules to be aligned, you can hit Option, right, hold it down, and then also press Shift. And when you do that, when you drag, it drags only along that horizontal or vertical axis, right? So you can't put the molecule up here, you can't put the molecule down here. The starting material is always going to be aligned with the product that you just copied, right? We need an H here, so all you have to do is highlight that oxygen and press O, and it will automatically put that OH in. You can cycle through, so if you just keep pressing O, it'll take it away, put it back. All right, now for the arrow, right? This is a reaction. So to get the arrow, highlight the arrow, press Option, and drag it down. Now this arrow is a little too big for the space in between the molecules. So we could do a couple of things, right? We can take one of these molecules and drag it somewhere else, right? So if we highlight this molecule and press Shift and hold it down, whenever we drag this molecule, it can only be dragged along that horizontal or vertical axis where it started, right? So this is a way of ensuring that if molecules are aligned, we can keep them aligned if we need to move them. So if you hold down Shift when you're dragging, then that should keep a molecule aligned on the vertical or horizontal axis, right? So we can do that and put the arrow in between the two molecules, right? Alternatively, we can decrease the size of this arrow, highlight it, and then drag it down in between those two molecules, right? And then for the reagents, hydrogen chloride, HCl, and then H2O and heat. So whenever we're drawing chemical formulas, the program can recognize those chemical formulas, and we have to tell the program this is a chemical formula. So what you do, if you have a chemical formula that you've typed out, you don't have to make every number a subscript. You can go up here and you can see that there's a little CH2 that says formula. If you keep your cursor there, if you click that, it will automatically recognize any chemical formula and change it to the proper format. Right, so we could bring the HCl down a little bit above the arrow, take the H2O and heat, bring it down a little bit below the arrow, right? And if we want to make these look nice and aligned, what we can do is highlight the HCl, press Shift, and then click on something else. And as long as you press Shift when you click on something else, it will include that in what you highlighted, right? So you can see these two different things are highlighted. If I go up to Object and Align, I can align them along any axis. So I want those to be centered along the vertical axis. So I'll do left, right, centers, right? And you can see it brings those two text boxes centered, so that they're centered with each other. Then I'm going to adjust just a little bit so it's around the arrow. Okay. The other thing that we can do, we can group things together, right? So right now, if I wanted to align all of these things, right, I would go up so that they're aligned along a horizontal axis. I can go up to Object, Align, top and bottom centers, and you can see what happens around the arrow because it's treating all of those things as individuals. Right, so if we want to make sure that this arrow with the reagents is treated as one thing, we can highlight all of those. If you hit Command G, it groups them together. And now when we highlight all three of those things, we can go up to Object, Align, and then align along the central horizontal axis. Right? We can also, if we wanted to align, you can right-click on any of the boxes and it will also give you that align function. If we want to make this look really nice, we can go up to Object, Distribute horizontally, and that's going to distribute those three objects so they're spaced evenly. All right, so there is our scheme. If you look at some of the other tips and tricks, so we've gone over highlight a structure, group a structure, copy and paste, the easy way to copy and paste. We've gone over the align, distribute, and then the atom labels. So let's look at some more of the atom labels, the stereochemistry, and then the bond multiplicity. Right, so in one of the chapters this semester, you're going to learn about stereochemistry and chirality, and it's going to be important to be able to illustrate those molecules in the right way. So let's look at this alcohol, right? And we can say that there are going to be two stereoisomers of this alcohol. One where the bond to that alcohol is coming out, so we'll represent it as a wedge, right? And then one where the bond to that alcohol is going back, so we'll represent it as a hash. What you can do when you draw this in, rather than going and clicking on the bonds in the toolbar, we can highlight the bond that we want to change. Let me zoom in on this a little bit. We can highlight the bond that we want to change, and if we want it to change to a wedged bond, you hit W and it will change it to a wedge. If you want to change it to a hashed bond, you hit H and it will change it to a hash. If you want to go back to just a regular single bond, say you made a mistake and say, I don't need to show the stereochemistry here. If you hit 1, it will change that bond to just a regular single bond. So wedge is W, hash is H, and then 1 takes you back to the normal single bond. Last couple of things. Stereochemistry, bond multiplicity. Okay, and then finally some of the atom labels. So you can see here's a list of some of the atom labels. I would say the ones that you will be using most often would be hydrogen, nitrogen. Carbon is kind of automatic. If you need to display a carbon, it'll put it in there, but it's kind of the default atom for organic structures, so we usually don't represent the atom label for carbon. Oxygen is O, and then fluorine, chlorine, bromine, and iodine, the halogens will be common. So if we go back to ChemDraw, right, you can see how you can cycle through those, right? So oxygen, nitrogen. If I want to show this specifically as a methyl group, I could put a carbon there, and then the fluorine would be F. Chlorine is kind of tricky because remember carbon is C, so chlorine is shift and C, and then bromine would be B, and iodine is I. So I would say you won't need to use much more than that. If you do need to write something, click on the text tool in A, and you can change that I to whatever you want. So maybe you want to say that this group is named Jerry. Right, now we can say that that's a Jerry group. If you want to align this differently, you can highlight that, right, and align it along the right-hand side of the word, or take it back, highlight it, and align it along the left-hand side of the word. You can center it, right? A couple of other things. So there are abbreviations for groups. Common abbreviations for certain groups in organic chemistry, right? So one of them would be like a methyl group. So ChemDraw recognizes these certain abbreviations, right? So a methyl group is abbreviated Me, and so if I write OMe to indicate that there's an oxygen with a methyl group also bonded to it, right? I can write OMe. You can see if I write it down here, OMe, ChemDraw knows automatically that I mean it's a methyl ether, right? So it automatically aligns it so that the Me is attached to the oxygen. It knows that the oxygen is the central atom in in this bonding group. So if you're trying to copy something and you see it says OMe here, right? If we type MEO as you would see it, right, now it doesn't look right. So for many of these group abbreviations, you can just type it normally, and then ChemDraw will recognize it and align it in the correct way, right? So let's see here, NO2. Let's write it over here. Right, so you can see it keeps the 2 with the O. It makes sure that the nitrogen is the central bonding atom. So that's about all. I know this is a longer video, but I hope it was instructive, and I do hope that you are able to use ChemDraw effectively and efficiently. What I would do is just practice drawing. You can go into any journal article or any find the structure of a drug and see if you can draw that structure of the drug. Have a great semester, and I will see you around Juniata.